A cone with the largest possible volume is cut from a cube with side length of 12 centimeters. Find the volume and surface area of the cone. So we'll start by sketching a picture and visualize what the heck's going on here. So I'll draw a lovely cube. All right, and then inside of this thing, maybe a blue cone. So it should have a circular base here. Its vertex should hit right there, dead center on that top square. There we go. And then maybe give it a little bit of shading here. All right, there we go. All right, now let's put some dimensions on this thing. So we've got 12. Hey, you're not supposed to be blue. We got 12 centimeters by 12 centimeters, and the height, of course, is 12 centimeters, which makes the radius here a 6. And then as far as the volume goes, the volume should be 1/3 pi r squared times the height. Well, we have our r, we just talked about it, it's a 6. Our height should be the same thing as the height of that cube. So let's put all our numbers together. The volume should be 1/3 pi. Our radius is 6 squared, multiplied times our height of 12. Okay, and then I think I'm going to cancel this 3 into the 12 common factor, and then we have a 4 left over. We got 6 squared is 36. Over here to the side, I'll do 36 times 4. That'd be 120 plus 24. We got 144. Okay, so our volume should be 144 pi, don't forget that, centimeters cubed. There we go. All right, we got our volume. And as you can see, there's just not enough room for us to do the surface area, so we'll just have to move this down a little bit. Okay. So for our surface area, we got, what number is this? 38. Let me draw a cone. All right, and we just said that the radius length here is 6. And then our height is 12. And then I'm going to shade, instead of the whole thing, just this right triangle here. Because you'll see in a second we'll have to solve the right triangle. Okay, because as far as the surface area is concerned, we've got pi r L, the slant height, plus pi r squared, the circular base. So we can get that circular base and the radius and all that stuff very easily, but we'll have to use the Pythagorean theorem in order to find that slant height. So using the Pythagorean theorem, I got 6 squared plus 12 squared is equal to L squared. 6 squared is 36. 12 squared, 144, equals slant height squared. 144, 36, that'd be 170 plus 10, 180. All right, and then final step, of course, is to take the square root. So my slant height is the square root of 180, which, you know, we could leave it like that, but like, why bother? Let's go ahead and make a factor tree and put this in simplest form. So we got, let's see, 18 and 10. 18, a 2 and a 9, and then 9 is a 3 and a 3. The 10 could be a 2 and a 5. All right. And then we've got a pair of 3s, so a 3 can come out. We've got a pair of 2s, so a 2 can come out. And then a little 05, got to stay in the house all by himself. So our final answer here for our slant height, we can multiply the 3 and the 2 together and get 6 square root of 5. Okay, so let's put it all together for our total surface area. Total surface area should be pi times my radius of 6 times my slant height of 6 square root of 5. And then our circular base, pi times 6 squared. And then it's a matter of just simplifying here. So as far as this 6 times 6 squared of 5 goes, I'm just going to multiply the two 6's together. So I treat this as if it's a 6x, and I would just multiply the coefficient. So 6 times 6, of course, is 36. Bring our pi and our square root of 5 down. And then as far as the circular base goes, 6 squared is 36. And it also gets a pi. Now, unfortunately, these things aren't like terms because you got this square root of 5 that's messing things up. So as far as the exact answer goes, you're pretty much done. Except units. Let's see, we got centimeters squared because this is area. Volume had centimeters cubed on it. Okay, and then maybe just box my answer here and call it done.